Okay. Now, the structure of today's presentation or webinar is going to be an introduction, which I've just done, a bit about myself, talking about sewage treatment problems in the context of where you might need temporary sewage treatment solution. Can I ask anyone who's on the webinar to mute their sound, please? Arthur, could you mute your sound, please? Thank you. And then I'm going to look at how you design a sewage treatment plant, especially a packaged sewage treatment plant, go through the terminology, what to look for in a design of a packaged sewage treatment plant. There's lots to consider in a temporary sewage treatment solution, some real life case studies, conclusion, and then questions and answers. Again, feel free to ask questions anytime, just unmute yourself and just ask, and it's interactive, so I don't mind that at all. So, my name is Tommy Butler, as I said. I'm a qualified pharmacist and also management qualification. I'm 15 years working as a specialist in packaged sewage treatment, vehicle wash water recycling, and pump station solutions. The company that I'm part of is a third generation family business, of which I'm the third generation. We are around for 40 years and have packaged sewage treatment systems in 50 plus countries. So we have a lot of experience. It's basically unrivaled experience compared to most practically anyone in the market. And we regard ourselves as a full service manufacturer in that we manufacture and design as well. So we will go right from the start of a project and do a full design with you, a customized design, which is suitable for planning, and work with you right from the start to the finish. And we maintain files in every product we ever manufactured, and we're still maintaining some of our original sewage treatment plants, which are more than 35 years old. So sewage treatment plant problems in the context of where you might use temporary sewage treatment. Now, there's some overlap in these categories, but it's good to define them in this way. So first of all, the municipal plant is overloaded. And municipal plant, I mean the one provided by either the water utility or the local authority. So this could be Irish Water, Thames Water in the UK. It could be a local authority in Australia. It could be the Water and Service Authority in the Caribbean. But basically, that the municipal plant is overloaded and can't take any more load. We'll discuss that more. Secondly, there is a crossover, but there's no connection available to a sewage treatment plant. This might be that you can't connect to the municipal plant at all, or that a plant is being built and not available yet, or that you might be able to pump in the future. But this can be more semi-permanent, but it is something you can put a temporary sewage treatment plant into counter. Something we're seeing more and more is a development is being built ahead of municipal infrastructure. Often in Ireland we cite, housing as a housing crisis as only an Irish problem, but it happens throughout the world. For example, in Brisbane, Australia, there is a definite shortage of housing, and they're talking about building small new towns outside Brisbane, up to 100 kilometers away. But this would be ahead of the municipal infrastructure. So temporary sewage treatment solutions will have to be put in place until the municipal infrastructure catches up. We did a very, very large, up to 5,000 population equivalent in Lusk before Portrain came on stream. So it can be done. And the real kind of maybe temporary sewage treatment plant situation is for oil, gas, military work camps and disaster reliefs, and also for construction sites, which is quite common in Ireland, the UK, and abroad. But oil, gas, military would typically be, for maybe a year, maybe two, but portability is very important for that. So the municipal plant is overloaded. So dig a bit more deeply here. This is a common problem which is not isolated just to Ireland. There's pressure on all infrastructures, there's pressure on spending. So sometimes, for whatever reason, due to planning, due to funding and various things, the municipal plant is overloaded. Now, typically, we find that the plant is actually organically overloaded rather than hydraulically overloaded. And this is really important to differentiate. Organically means it can't treat any more organic load, BOD, sphenic solids, or ammonia or phosphorus, which means if you treat to a set standard, you can actually discharge into the municipal plant. And this is an advantage for the municipal plant in a lot of ways because you're actually diluting the stream coming into it if you're treating to an acceptable standard, which makes a discharge from overloaded plant better. So how do you deal with this? Well, you install a modular packaged sewage treatment system for a development, and then you treat to a specified standard and discharge into the actual municipal plant. In Ireland, we've many different locations like this, from Kings Court and Cavan to Arklow to Middleton and County Cork, in France, in Brittany, in lots of other different locations too, but there to name a few. And this is usually temporary. When I say temporary, it can be anything from 1 to 10 years, what we experienced. The median will be 3 years, but typically it goes a bit over what the projected municipal plant upgrade build is. But it's a very sustainable way to get housing development, office development, commercial, to get it built and get people into it when there's housing crisis, when the municipal plant can't take any more organic load. Now, you can also get situations where it's hydraulically overloaded. So in this case, you have to look to discharge into a water course, or if there's space available, a percolation area, because typically the standards required in the percolation area are less stringent than going to a water course. Now, typically water courses, people, most planning authorities want to avoid any pollution, but if it's for short term and there's pressure in housing, there can be a kind of, what would you say, a medium kind of standard produced just for a short-term discharge. So, and when I say timescale 1 to 10 years, and these plants may need expansion. We've had situations where we put in one plant expecting the municipal plant to be available, but it wasn't, so we had to put in two or three more, and then no connection available. Well, this is typically where there's huge demand for housing and the municipal infrastructure is not keeping up. So typically you will be discharging from this, or there might be some chance again of connecting to a sewer, but this for housing, commercial, tourism, it can be anything from 3 to 10 years. It can be semi-permanent, and typically for this kind of situation, capacity is added in steps. We're actually working on a project with our partners, Nova Process, at the moment in Perth, Australia, where it's been built just ahead of the municipal infrastructure, so it's been treated on a temporary basis and then discharged. And I said true temporary project where there are typically camps set up for military, disaster relief, gas and minings, and construction sites, and they're typically 1 to 3 years. So just moving on to a construction site and camps, you might think this is not necessarily relevant to you, if I'm talking about mining and gas, but it is certainly in Ireland, UK, and European context, because there's a lot of infrastructure being built away from where sewers are. If you think about wind farms, electrical transmission, or even tourism locations. So the traditional solution was just put in a septic tank and put all the sewage generated by the workers on site into it and get it tankered away on a daily or weekly basis. But this has a very high cost and it has a high environmental cost as well. So the new approach to this will be treating on site with a packaged sewage treatment plant, either discharging if suitable on site or adding something like UV disinfection and reusing it on site, which it makes the whole thing really, really sustainable. If you disinfect, you can reuse it for non-potable purposes such as wheel washing, road cleaning, dust suppression. But the big thing is you can reuse it in the toilets because you actually don't need potable water to flush a toilet. And there's ways and means around that. But this has been really successful solution, and it has a really good payback and we use on multiple projects. Oil, gas, and mining, they're typically remote sites and they come with a strict discharge. For example, we did a project with Bechtel in the Algerian desert, and obviously it's not populated or anything like that, and you think you could just discharge, but the actual there was strict environmental discharge standards, so they installed packaged sewage treatment plants on their camps, which are every 500 miles about, and they disinfect and reuse the sewage to cut down their potable water use as well, which in the desert was really important. But they move the plants regularly, so a portable plug and play solution they can empty, just disconnect and bring to another site is really important. And then for disaster relief, like Médecins Sans Frontières and the UN. It's really important, a portable plug-and-play solution that they can get going really quickly, because the big thing about treating sewage in a disaster situation is stopping the spread of disease. So design of this is how do you design one? What do you look for? So the first thing to look for is trying to size it correctly. Um, if you had um, accurate flows and inlet levels for BOD and suspended solids, for example, it's very easy to do, but typically you don't have it for a site. So first thing to emphasize is sewage treatment plants are sized on the organic load, not the flow. Um, we often come across flow, what I call flow bias, in that someone adds up the flow to be, for example, I've got a detailed example coming up, about 5,000 liters for an office. And this looks like, okay, in Ireland in general, it's about 200 liters produced by one resident of sewage per day. But if you divide the 5,000 liters by 200, you get 25 population equivalents. And sewage treatment plants are size and population equivalents. But if you dig down and actually look at it in an office situation, it's far more concentrated. So you actually need a 55 population equivalent plant to actually treat the BOD, suspended solids, and ammonia. So if you went on flow alone, you'd end up undersizing the plant by organically by over 100%. So you're not going to meet your discharge standards, which is going to cause a lot of problems. And the Irish EPA produce a great table which allows you to look at different array of situations, from offices to hotels to function to clubs and everything like that, and get a rough approximation of what the flow and the BOD generated by one person using it is. For example, in a population equivalent, one person resident in a house apartment generally produces 60 grams of BOD and 200 liters of flow. This is the organic content is relatively constant from country to country, where the flow can vary up and down depending on water use. But for example, if you look at the office and canteen, you can see there that the flow is 30 liters and the BOD is 20. So that would give, instead of a normal concentration of BOD of maybe 667 milligrams per liter, sorry, that would give a concentration of 670 milligrams per liter, which is over double what the normal concentration of BOD in sewage is, which is 300 milligrams per liter. So you can see how going on flow alone um, will can make you make the size of the plant wrongly. Um, Obviously, what final effluent is required. If you're discharging into an already overloaded plant, typically what you'd be aiming for or is the actual standard that the plant has to produce. The default generally is BOD 25 milligrams per litre and suspended solids 35 milligrams per litre, which is European wastewater discharge standard, but you can go many ways in between. So other factors, what to consider. Is there a sewer connection, or is it direct discharge? Discharge has a lot more to do. Do you need to size is a percolation area available, or do you need to go to direct discharge? Now, if going to direct discharge or water course, you may need an assimilated capacity study and things like that. And typically, you're aiming for far more strict discharge standards, which might include ammonia, total nitrogen and phosphorus, and BOD and suspended solids probably lower than 20 milligrams per liter and 30 milligrams per liter, which is standard. The flow pattern is something very important to also consider. In locations, especially hotels or tourism locations, you can get a high concentration of flow over the space of a few hours, maybe the morning, the evening, or peak times. And typically, well, it's the same for any sewage treatment system. They like to be fed regularly rather than one big meal. So what a balancer screen tank, it does two things. It will fill up during peak times and will pump forward slowly via timed pumps during a non-peak times. So say for example in a hotel or a housing development with a lot of commuting, it would fill up rapidly in the evening, and then it would actually pump down at night, giving spreading the flow to the sewage treatment plant, which typically improves flow a lot. And these tanks can also be used with the baffle and macerator pumps to screen from non-soluble solids. How long is the plant going to be in place? Well, the actual planning authority should give an indication when the municipal plant is going to be one put in place or it's going to be upgraded. Typically, yeah, a conservative design is to go a few years above this. Is it going to be a phased development? A lot of housing, a lot of commercial is a phased development, which means that you may not want to put in a different amount sewage treatment to match the phase development. So instead of maybe two 500-person systems, you might put in four 200-person systems over time to spread the cost. What are the civil works? This is really important. The easiest way to put in a temporary sewage treatment plant is put in a pump station and pump one that's fully above ground. Now, not all systems do this, so something to watch out for. Or you also really want to aim for a system that can go, if it's going to be buried, that doesn't need a concrete surround, because if it does need a concrete surround, it's not going to be able to be reused at another location after, and there could be substantial decommissioning works with it and environmental cost. Effluent reuse is what I mentioned. If you add a UV disinfection or chlorination at the end, especially remote locations, reusing it for non-potable use is very viable and environmentally very friendly. Financing is something very important from a developer or financer point of view, in that if it is an all-in-one unit, um, it can be financed by hire purchase, which can spread the cost over a number of years. Obviously, doing any housing development or commercial development, the financing is always the main thing that will determine whether it can go ahead or not. So if you can spread the cost and phase it, can make things far, far more easy to do. And also portability and relocation. Um, for temporary sewage treatment, having a system that can be moved to another site is really important, or has a resale value after. And from an environmental point of view, this is important. And again, can the system go above or below ground? Above ground is the easiest way, but if you go below ground, you can often get gravity flow in and not have to use pumps. So a system that can do all of the above is what you really want. So we already looked at the EPA table. So I'm going to quickly touch on sewage treatment terminology. I'm not going to spend too long on this, and show you a worked example of how you calculate the size of a temporary sewage treatment plant in a real life context. So a population equivalent, as I said, is typically 60 grams of BOD, also 60 grams of suspended solids, and typically about, in Ireland, 200 litres of flow. Now this can vary from anything from 100 to 300 litres of flow depending on the location, but typically the organic is very stable. And the biochemical oxygen demand, as I said, is the pollution potential of the sewage, or how much oxygen it can strip out of sewage. And suspended solids are the solids that are left in suspension when you take a sample, and they are the benchmark for any sewage treatment inlet or outlet samples. So you'll always have BOD and suspended solids. If you're moving on to discharge to a water course, typically more and more you would see an ammonia standard, because ammonia-rich sewage, with ammonia as the main component of fertilizer, can cause eutrophication and algae blooms and fish kills. This is typically about 8 grams per population equivalent. Typically in Ireland, you'd see a concentration of about 40 milligrams per litre, with BOD and suspended solids about 300 milligrams per litre. And then moving on to the nitrate, which is is when you remove ammonia, it gets transformed initially to nitrate, and then to actually lower total nitrogen, you need to do a final step of anoxic denitrification which converts nitrate to nitrogen oxygen gas. So that's how you lower total nitrogen. And then phosphorus or orthophosphorus, it's mostly in detergents. Obviously, again, it can cause eutrophication, typically about 14 milligrams per litre, or 2.8 grams per population equivalent. So this was an example of where there was a new office university building going up with up to 165 staff, with no commercial cooking on site. And we went to the EPA table and saw that one office staff will produce BOD 20 grams of BOD per day, and 20 grams of suspended solids in a flow of 30 litres per person. So to work out the population equivalent, we work out the total BOD, which is 3,300 grams. Then the population equivalent is worked out simply by taking the total BOD, which is 3,300 grams, and divided by one population equivalent, which is 60 grams, which gives us 55 population equivalents. And here again, this was the example I was quoting earlier as regards flow bias. You can see the flow is only 4,950. So if divided by 200 liters, you'd only get 25 population equivalents. So it would mean that the plant would be vastly undersized. And you can see by dividing the BOD total BOD by the flow, you get 667 milligrams per liter, which is really concentrated influent. And you take it that normally it's 300 milligrams per liter. So that's the flow bias I was talking about. So you need to always work on the organic load rather than the flow. And the final effluent in this case was BOD 20 milligrams per liter, spent solids 30 milligrams per liter, ammonia 5 milligrams per liter, total nitrogen 50 milligrams per liter, and phosphorus 5 milligrams per liter. And this is what you typically see for discharging to a watercourse if no connection is available. And the other consideration is the temporary plant for 3 to 5 years. So I can go into this more detail. We do have a size and selection manual which goes through calculations and how to do them, which we can share the link to everyone in the presentation after. But to work out what load the removing ammonia puts on the plant is you take, I said one population equivalent is 8 grams. So you multiply that by the total BOD load, which is 55 population equivalents, which give you 440 grams of ammonia to removed, and dividing that by the total flow gives you 89 milligrams per liter. Obviously, we are allowed 5 milligrams per liter in the discharge, so the total removed amount is 84 milligrams per liter. And if you take 84 milligrams per liter and multiply by the flow, you're getting 416 grams of ammonia needs to be removed. Now, this is where it gets slightly tricky. The bacteria that remove ammonia are quite temperature sensitive and quite fragile. So it takes, in a warm climate like the Caribbean or Australia, it takes 3 times the oxidative capacity to remove 1 gram of BOD relative to ammonia. And in a more temperate climate like Ireland, it takes 4 times the capacity. So you can see this is actually located in Cork and Ringaskiddy. So I'm multiplying it by 4. So the total equivalent capacity you need in terms of BOD is 1,663 grams and then divided by 60 grams, which is 1 gram, 1 population equivalent of BOD equals 28 population equivalents. This is added on to the 55, and we're moving towards our full population equivalent calculation. And also, to get anoxic denitrification, you need recirculation back to the start, and the actual nitrate-rich sewage mixing with sewage in a non-oxic environment, which means you don't add oxygen, you get anoxic denitrification. I don't have time to go into the full process in detail, but I can answer questions at the end, and we have full explanations on our website and our blog. And to remove phosphorus, normally it's with ferric sulfate or aluminium sulfate dosing. And this is this bulk sludge, and it's also biocidal, so you need to add about 15-20% extra capacity. So the total design, and this is a very complicated example, but it's something we can help with just to show you how it would be done if you're discharging to watercourse. So 55 population equivalents of BOD capacity, 28 population equivalents of ammonia capacity, and multiplied by 150% to take into account ferric sulfate dosing gives you 95 population equivalent plant required. And in our case, this is what we installed was a BL 1000 blivet, which is 100 population equivalent, and that is in the Beaufort Centre or the Marai Centre in Ringaskiddy. And as I said about timelines being conservative on it, this is meant to be in for 2 or 3 years, and it's still there 8 or 9 years later. This is in the corner of a car park, and it's above ground, as I said. So it just literally was put in, the inlet and outlet pipes were connected, and the electricity, and it's ready to go. And when eventually it's taken out, it's going into an already pre-made sewer. So it's only a matter of taking it out and rediverting the sewer for untreated sewage to go out. So, is there any questions at this point? Are we okay? Okay. How does a typical package wastewater treatment plant work? Typically, you've got primary settlement to start with, where gross solids of about 80 to 90% are taken out, along with BOD of about 20%. there's also sludge storage because sewage biological treatment creates sludge, roughly about between 3 to 5 liters of sludge per population equivalent per week. Then you got aerobic treatment. All effective sewage treatment is biological, and it's aerobic. Septic tanks do it differently, but they're actually quite poor at treating sewage. So you could have anything from a biodisc to rotating biological contactor to active aeration to a moving bed reactor. And then invariably there'd be final settlement, a humus tank with sludge return back to sludge holding. And in some systems, if you have net hydraulic lift, you recirculation back to the start, which can allow you to do extra nutrient removal or adjust the flows in low and high flows. So we're moving on to you've got a site, you've got a housing estate, you've got a development, and you can't go into municipal sewage treatment plant, so you're looking at temporary sewage treatment solution. So when you're designing yourself or something's presented to you, what to look for? Well, firstly, the sewage treatment and water industry is a conservative industry, and that means that you that typically a product takes 3 to 5 years to develop and can take many years to approve. So you need a solution with comprehensive design and references. Um, for temporary sewage treatment, you really need an all-in-one plug-and-play system that can just be brought to site. You don't have to do much civil works. Can be easily put in, just connecting the inlet and outlet pipe and electricity, and it's ready to go. And emptying it and doing a reverse, it's ready to move to another site. That can be delivered by a truck or container. The solution, as I said, that can go above or below ground without a concrete surround. If it needs a concrete surround, it's going to have to be, it's never going to move from the site again. So it's really not a true temporary sewage treatment solution. And there can be big decommissioning costs after if this is not taken into account. On a site like this, you need the lowest power and maintenance because most of these sites would typically start in generators. So something like a rotating biological contactor solution is the lowest power available, where a blower solution can use 9 to 10 times more of this, even 20 times more. So it might not be a viable solution to start off with. How close it is going to be to a housing development. Typically, you're looking at setback about 50 meters, but with temporary sewage treatment, you can often get you can often get uh, uh, you cannot often a very close area is required to the to housing. For example, we have a housing estate in Eden Derry where the setback's only 5 to 10 meters. I can show you later on, but the solution was there. Enclosed packet sewage treatment plant in a steel tech type shed, which allows development to go ahead. It needs to be obviously easy portable and relocatable. So it has so it has a resale value and everything like that. And then also a modular solution that can be installed in phases is best typically because it allows you to spread the costs as I said and can be put in as developments continue. For construction sites or remote locations or arid locations, UV disinfection being added at the end allows for reuse. And another important thing for developers is said that it can be financed by hire purchase, and this can only be done if it's one complete unit. So just quickly, just to talk about this is what we base our designs and everything on. It's our Blivet package sewage treatment system. So it would fulfill everything I was talking about. It's an all-in-one, ready to go plug and play system that's extremely compact. It can go above or below ground without a concrete surround. The biggest unit can treat up to 500 full-time residents or population equivalents, and there's lots of units in between. It can slip into a 40-foot container for transport, which is really important for any international projects. Any projects in Europe, it can be road transportable, ready to go. It needs an hour per week of maintenance. Very low power consumption, even for 500 people, it's only 15 kilowatt hours per day. Excellent lifetime value. I mean by this, these units are built to last. We have units still functioning 35 years. The spare parts requirement is very low. It's very easy to move and transport. Portability, to install it, you just need you can put it above ground with concrete slab or below ground with concrete slab and just backfill it with excavated material. Connect the inlet outlet pipe and electricity, and it's ready to go. And to remove it is simply just is doing it in reverse, along with fully emptying it via suction tanker. It's road transportable, and it has, as I said, it has a 35-year global track record. So I'm just going to show you a quick video of how it works, and this shows you how, like, if you're not familiar with packaged sewage treatment systems, how they typically work. It's only 1 minute. Thanks. That hopefully gives you a view of how a packaged sewage treatment plant works. It's a good video just to show you that. So now I'm just going to go on to a few real life case studies, which shows, how you can deploy temporary sewage treatment to allow development to go ahead, which is really what the crux of the problem is and what you want to solve. So this is we're approached for a housing estate in Arklow and Wicklow. As you probably know, Arklow and Wicklow didn't have any real sewage treatment for a long time. It's being discharged into the river. They're currently finishing off a new municipal plant, but this development wanted to go ahead. And obviously, there's a huge demand for housing in Ireland, especially, but everywhere. So this is a good solution to show how you can actually get around that. So again, the actual plant, the actual treatment was organically rather than hydraulically overloaded. So there was agreement from Irish Water and from the planning authorities that if the sewage at the site was treated to BOD 25 milligram per litre and suspended solids 35 milligrams per litre, which is European wastewater discharge standard, which is a great benchmark for sewage treatment and the minimum you'd ever go at, that it could be discharged into the sewer until a municipal plant uh, came on stream. Um, what the engineers and developers wanted was they wanted a solution that was easy to install, commission, and maintain, and also decommission. And they were very much focused on a solution that could take it out after, and they could redeploy or sell on. So the full design was done by BMS in conjunction with the project engineers, and it was actually, as I said, it was on a phase basis, so the costs could be spread, and the sewage treatment capacity could be increased as the housing was built. So the development is actually it has been fully built for quite a few years, and the plant has been operating quite a long time now. So initially we put in what we call one BMS BL 2000 Blivet, which can treat 200 population equivalents. So the first phase was 34 houses, which 136 population equivalents. The second phase was 26 houses, which just over 100 population equivalents, and the third phase was the biggest phase, which was with 137 houses and brought to 548 population equivalents, bringing the total capacity required of the plant to 800 population equivalents. Now, the reason it was done like this, we could have put in two of our 500-person plants initially, but again, the cost was spread throughout the project and everything like that. So it allowed the developers to spread and add capacity as they completed housing. So you can see it there. That's the four units in place. They're below ground, and you can see they don't have a concrete surround. You can see the electricity going into them. So in the end, removing will be just excavating, fully emptying the plants, disconnecting the inlet and outlet pipes and the electricity, and they can be sold on or redeployed to another site. So learnings from the project, there's always learnings from every project. We've experienced a lot of things in our 40 years, but we don't know everything. And every project always has unique challenges. So on this site in particular, we had a big problem with non-soluble solids, tampons, baby wipes, rags, and everything coming down. Um, the fact that these are state provided houses means um, with no disparaging on the residents, but that it tends to be more non-soluble solids coming down. So in conjunction with the engineers, we initially designed a gravity splitting solution to reduce cost, but the pipes kept blocking. The blivets were fine. So what we came up was a screening balance tank, which I talked about, which is a GRP tank fitted with macerator pumps, which operate in a timer, and a baffle in the inlet area, which captures a lot of the gross solids. So the maintenance is kept down there. And it also is great because it allows a very even split of the actual flow into it over the four blivets. So it's a solution, especially when for a phased development, we'd really recommend, and it balances out flow surges very well. Again, this is a portable balance tank that could be relocated. The spreading the cost or on a phase basis was really important to the developer and something we bore in mind for again. And the other thing is that regular maintenance contract needs to be put in place in these sites because a lot of construction sites have different workers coming in and out and everything like that, and the plants can be neglected. So it's really important to put in place. And finally, on a construction site, and you really really need to engage the developer that the people on site, subcontractors especially, aren't putting paint, grease, stone, and everything down, flushing them down the toilets, which is a common way for them to get rid of them, and can initially was causing some damage to the plant, but we got an order eventually. So you can see that was the balance tank with the flow split between it, and with the provision for two extra units, which won't go ahead now because the actual arc flow main plant is very nearly finished. But it's a good point. If you put the civil works in place initially, it makes adding capacity really, really simple and only a day's work. And that's the balance tank there in place. So again, does need a concrete surround. Now, moving on to a temporary sewage treatment solution for tourism, and we're moving to France for this because, as I said, it's not just an Irish problem; it's an international problem. This was a chalet and camping site in Brittany, and the local municipal plant is overloaded and didn't have extra capacity, but they wanted to expand and take in more clients over the summer. So what we did was we worked with the French company, a French partner company called Symbiose, and we designed a temporary sewage treatment solution, again to EU discharge standard of BOD 25 and spend size 35, and it's connected to the municipal plant, which can take the hydraulic load but not the organic load. What was really important here was that it was a plug and play unit which would go in the corner of the site that was really compact, and that was allowed easy installation, commissioning, and decommissioning because the funding for this is going to be via hire purchase, and it's going to be rented out again after it's not required in this site. So we put it in the corner of the site. So this went ahead in two phases. Firstly, one of the BL 2000 blivets you already saw there for up to 250 people was put in, population equivalents or residents put in. And then the second phase was a BL 4000 blivet, which can treat up to 500 population equivalents. And there's some good pictures here. At the moment, the BL 4000 is running, and I can show you that actually came out of a temporary sewage treatment plant in Lusk. We were treating 5,000 people, and it's 15 years old, and just shows how good the plant is. It was refurbished and ready to go. And the BL 2000 is now in the French island Mayotte in the Indian Ocean. So again, it shows the portability, and that temporary sewage treatment is required everywhere. So you can see the calculations. Sorry. We can see the calculations we did there. It's fairly standard. We worked out what the BOD was on both projects, and so we ended up with 250 population equivalents initially, and another 250 population equivalents for the phase two. So at the moment we're treating phase one and phase two with BL 4000 blivet, and you can see it being delivered. Hello, hello. be lowered into place. And then you can see the actual plant in place with the actual van beside it. So learnings from this project, quick solution that plug and play and commission in one day was vital. No screen was required because there's less solids. Sorry, could you, if could you mute your mic, please? Could everyone mute their mics, please? There's less solids in France, so no screen was required. Excuse me, 1 second. And the financing was finance the financing was by hire purchase. And this was a 15-year-old plant that we refurbished. That was that we refurbished and put back into place. And the BL7000 went to Mayotte, and there's very good maintenance on it. And even though it's so close to the actual units, there's actually no odor issues and things like that as well. So moving on. So you can see a lot of different BMS Blivet can be used in a lot of different situations, from permanent to temporary to disaster relief. You can see in the corner that was Lusk in County Dublin, where we reached up to 5,000 population equivalents, which is the biggest temporary sewage treatment plant we ever did, and was added in steps. Sorry, I just muted that. So that's Lusk again. So there are 500-person plants that were added, one after the other. So the total capacity treat was 5,000 population equivalents, and they were all redeployed, and they're in lots of different locations. This is Centre Parks, Longford Forest in Ireland. So we treated all the sewage from Sisk and Robridge during the construction project, and it was reused for toilet flushing, wheel washing, dust suppression, road cleaning, and the payback was within a year for Robridge and Sisk, and that unit itself is now on a 6 different location. It was also in Avondale House. It was in Dublin Airport, a lot of different locations. So they're portable and they can be reused, and it's a really sustainable solution. This was a project we did in Ireland where an SBR system was failing and the hotel was going to be closed down. So we put in a temporary BL4000 Blivet, which is 500 population equivalents, to help to take over the excess load in the plant. And within a year, this was integrated into a brand new Blivet packaged sewage treatment plant. So temporary sewage treatment for overloaded plants, if there's a temporary excess load, is a very viable solution too. This is what we talked about. This is in County Offaly in Ireland. That's 2 BL4000 Blivets. They are literally 5 meters from a house. And what we did was we innovated a solution where they're putting a steel tech shed with ventilation on it. And actually most residents don't know they're actually there, so they're working really well at the moment. This was a temporary solution in Newfoundland in Canada. As you can see, it was very cold there. And yes, sewage treatment does work in very cold conditions once there's adequate sewage flow, because sewage is invariably warmer is warmer than the ambient in very cold conditions, and it's invariably cooler than in really warm conditions. And we have Blivets working in Canada down to -40, and I think our record is plus 35 in the Middle East. We did all the US military camps in Iraq on a temporary basis. They were in grey for the time, and that's an example of one of them. Obviously, we don't have any more pictures because it was classified at the time. So, in conclusion, there's a lot of developments which can't go ahead at the moment, especially housing, commercial tourism, where the local municipal plant is overloaded, and typically it's organically rather than hydraulic overloading. So a temporary sewage treatment plant is a very viable and good value solution to allow a development to go ahead. Typically, most planning authorities will accept it. We can do the full design and planning for submission to planning, and they're actually working at multiple locations around Ireland and around the world, enabling housing to go ahead and a commercial developments to go ahead. and can be used from a timeline from 1 to 20, 30 years if needs be. They can be moved after, and what you really need to look for is a self-contained modular solution. Every project is unique. Um, we can work with you from the start to the finish, and we have lots of experience. We can do all the design. And one last thing I might highlight is we have a handbook called the BMS Size and Selection Handbook, which goes through how to select a packaged sewage treatment plant for different inlet and outlet standards and different scenarios. I know I went through the calculations very quick, but we have limited time. So I might just move on to any questions anyone might have. I'm happy to answer if you just mute and ask. Otherwise, if there was some questions sent in, I can go through before the end. Okay, feel free to interrupt me anytime. The first question what sent was the biggest temporary sewage treatment plant we can install. Well, our biggest single unit can do up to 500 population equivalents, and this would be about the size of a 40-foot container. We don't go bigger than that because for shipping internationally and on a truck, that's the biggest you can get. But you can expand in 500-person steps up to, as I said, the biggest we did was 5,000 population equivalents. And you can put them in different parts of the site and everything like that for decentralized sewage treatment, which we also done as well. But it's only a question of adding modules as the load increases. Um, is the water from the blivets we give you disinfection discolored, or is there any odor? And if so, how do you use them in the toilets then? Well, that's a good question. We have good data from Centre Parks. The disinfection was very good, but yes, there were it was discolored and slightest odor on it. But you don't need potable water to flush a toilet. So a really easy solution is to use biodegradable toilet blocks, which are readily available. Now they have to be biodegradable rather than chemical ones, but that covers over any odor or any smell, and it has been used on occasions and people haven't commented whatsoever detrimentally. Um, when if you use in that kind of situation, construction site, 80 to 90% of water use is from flushing. So if we're reusing that and then there's some wheel washing and things like that, you probably need to top up the system. So it really cuts down on potable water use a lot. What's the longest we operated temporary sewage treatment plant for? Well, nearly 15 years in Lusk. We have units from that we took out into Leak that were reconditioned after 15 years and eventually went to Fiji and Haiti. And at the moment, we have a plant down in Ringaskiddy in Cork, which is going nearly 10 years. And can your designs be submitted for planning? Yes, we do detailed customized designs for every project, and we look into what's the best solution for that. So typically they have been submitted to we've done them in French, we've done them in English, we've done them around the world, and they have been very suitable for planning. And we're always there to ask any questions or help any planning submittal. And if discharging to a watercourse, what effluent standard you're likely to need? Well, I touched on that already, but you're going to need a bigger plant. You're going to need more complex sewage treatment, probably with denitrification to remove total nitrogen, extra capacity to remove ammonia, and probably phosphorus removal. It's something we've done a lot. We have Ireland has some of the tightest effluent discharge standards in the world, so we've a lot of experience, a lot of track record. So we can certainly look into that and doing a solution for that. So, is there any other questions on temporary sewage treatment? Well, you can, if you have any questions, you can also email me or ring me. Our website's www.butlerms.com, or you can email me on tommy.butler@butlerms.com. I'd be delighted to answer any questions you have. Well, thanks for joining us today in our webinar. We hope to do webinars on different subjects in sewage treatment and surface water treatment, monthly or bi-monthly, depending on the workload. But thanks again, and we look forward to working with you.